August 2025. The James Webb Space Telescope captures data that shouldn't exist. An interstellar comet, the third ever detected, is acting less like a frozen ball of ice and more like something with a mission. This is not science fiction. This is 3I, Atlas, a visitor from beyond our solar system. But unlike the two before it, this one is breaking every rule we thought we knew about interstellar objects. Harvard's Avi Loeb has already raised the alarm. He suggests 3I, Atlas may not be a random wanderer. Its trajectory looks almost scripted. Its chemistry defies expectations. And its speed, the fastest ever measured, has scientists asking questions they never wanted to ask. The evidence is mounting, and what they're finding forces us to confront a possibility humanity has always feared. What if it isn't natural? When Webb and NASA's upcoming SphereX mission turned their instruments on 3I, Atlas, they expected the usual comet signature, water vapor dominating the readings. Water is always the first element to reveal itself as icy bodies warm near the sun. But this time, the results shocked the mission teams. Instead of water, the comet's chemistry revealed an extreme ratio: 8 parts carbon dioxide for every 1 part water. To put that into perspective, most comets in our solar system show the opposite: water dominates, with smaller traces of carbon dioxide. Here, it's reversed on a scale never seen before. 3I, Atlas is venting massive amounts of carbon dioxide while barely releasing water vapor. Almost as if it's deliberately cloaking itself. After all, carbon dioxide produces dense, opaque clouds, the perfect camouflage for hiding whatever lies at the core. But the chemistry was only the beginning. 3I, Atlas shattered another record that left astronomers speechless. This interstellar visitor is racing through space at 130,000 miles per hour. The fastest speed ever recorded for any comet or asteroid entering our solar system. At that velocity, it could circle Earth in just 11 minutes. Interstellar objects usually drift. They coast along predictable paths, their speeds reflecting the slow physics of billion-year journeys between stars. But 3I, Atlas isn't drifting. It's moving with urgency, like it has somewhere to be. How could a natural object be accelerated to such extreme speeds? Random debris doesn't just launch itself across the galaxy like this. Now combine those anomalies, an impossible chemical ratio and a record-breaking velocity, both wrapped in a carbon dioxide smokescreen. Two highly unlikely traits converging in one object. That alone would make it the strangest comet ever seen. But then came the trajectory, and that's where things start to feel almost scripted. When astronomers mapped its path, they noticed something extraordinary. 3I, Atlas is traveling on a trajectory tilted only 5 degrees from the ecliptic plane, the thin, invisible disk where nearly every planet in our solar system orbits. Random interstellar visitors don't do this. They usually arrive at steep, chaotic angles, diving in from above or below. Yet this one slides almost perfectly into the planetary plane, as if positioning itself to tour the solar system. And tour it does. First, it passes Venus at just 0.65 astronomical units. Then Mars at 0.19 astronomical units. Finally, Jupiter at 0.36 astronomical units. Each flyby is positioned exactly where you'd expect if the goal were gravitational assists, or planetary reconnaissance. The odds of a natural interstellar comet just happening to thread this sequence of encounters are astronomically small. Like throwing a dart from another continent and hitting the bullseye. Then came the timing. Its closest approach to the Sun, perihelion, will occur on October 30, 2025. That's when the comet will shine brightest and vent most actively. But at that exact moment, Earth will be positioned on the opposite side of the Sun. hidden from view. If you were trying to avoid detection, you couldn't plan it better. Approach when the target can't observe you directly. Use the sun's glare as your shield. Conduct your mission in the shadows. Loeb put it bluntly, this could be deliberate concealment. Let's slow this down. If you were sending a spacecraft into a foreign star system, what would you do? You'd stay close to the planetary plane where all the interesting worlds orbit. You'd plan flybys of key planets for data collection and course correction. You'd time your closest approach to maximize both concealment and efficiency. That's exactly what 3I, Atlas is doing. Coincidence? Maybe. But it starts to sound less like a wandering rock and more like a script. And history tells us this isn't the first time an interstellar visitor has shaken our assumptions. In 2017, Oumuamua arrived. It was unlike anything seen before, accelerating mysteriously, reflecting light in patterns that suggested metal, and shaped so elongated it looked engineered. Mainstream science eventually explained away most anomalies, but the debate revealed something important: our deep unease when the unknown arrives from the stars. That fear isn't new. 5,000 years ago, Babylonian priests recorded strange sky visitors as omens, signals of change that demanded sacrifices and royal attention. Ancient Egyptians went further, collecting meteorite iron to forge sacred objects like Tutankhamun's dagger. In the Cold War, early satellites provoked global paranoia. Every moving dot in the sky was suspected of being a spy. Across eras, humanity has always asked the same question: what if it isn't natural? 3I, Atlas puts us back in that position. Except this time, we have the tools to investigate. And the possibilities range from fascinating to unsettling. Loeb and others have outlined 3 scenarios that keep space agencies on alert. Scenario 1. The Oberth maneuver. At perihelion in late October, the comet will be closest to the Sun. If it has propulsion, firing engines at that moment would amplify its thrust dramatically. Even a small course correction could redirect its path into a bound orbit, potentially closer to Earth. That's why astronomers are running calculations on possible orbital shifts. Scenario 2. Swarm release. What if 3I, Atlas isn't the probe, but the carrier? Its dense carbon dioxide coma would be the perfect shroud for deploying dozens of smaller seed probes, each no bigger than a satellite, scattering toward different targets. The Galileo project is already monitoring for unusual aerial phenomena around perihelion, just in case. Scenario 3. Stealth craft. What if advanced civilizations use hollowed-out asteroids as camouflage? Natural shells hiding sophisticated technology. With the thick carbon dioxide coma obscuring 3I, Atlas's core, we can't see what's inside. If something wanted to hide, this would be the perfect design. Now, to be clear, no one is declaring aliens. NASA's official position remains cautious. 3I, Atlas behaves like a comet, and likely is a comet. But the anomalies are undeniable. And when respected scientists openly discuss the possibility of artificial design, it means we're in new territory. Here's the bottom line. 3I, Atlas isn't just another icy rock passing through. It's moving faster than anything we've recorded. Its chemistry is upside down. Its trajectory is suspiciously precise. And its timing suggests it doesn't want to be seen. If it's natural, it challenges everything we know about how comets form and travel. If it's artificial, it could be the first evidence that we are not alone, not microbial life in hidden oceans, but something technological. A civilization capable of interstellar probes. Either way, the implications are enormous. We have a narrow window before it disappears behind the sun, and what we learn, or fail to learn, could define this era. For the first time in human history, we might be confronting the ultimate question not as myth or speculation, but as observation. Is 3I, Atlas the strangest comet ever discovered, or the first probe we've ever detected from beyond the stars? The universe has just thrown us a mystery. And how we respond may one day be remembered as the moment humanity realized it was not alone.